Welcome to a brief introduction into the history of modern animation. The earliest form of modern animation was the zoetrope, created in 1834 by William George Horner. The device is essentially a cylinder with vertical slits around the sides. Around the inside edge, there's a series of images, and when the user looks through these slits, it gives the illusion that the images are actually animated.
The phenakistoscope uses a spinning disc attached vertically on a handle. Around the center of the disc, a series of pictures are drawn corresponding to frames of the animation. Around its circumference was a series of radial slits. The user would spin the disc and look through the moving slits at the disc reflection in a mirror. The scanning of the slits across the reflected images kept them from simply blurring together, so that the user would see a rapid succession of images with the appearance of a motion picture. A variant of it had two discs, one with slits and one with pictures. This was slightly more unwieldy, but needed no mirror. Unlike the zoetrope and its successors, it could only practically be used by one person at a time.
After the phenakistoscope came the flipbook. The first flipbook was patented in 1868 by Johns Barnes Lint. Flipbooks were yet another development that brought us closer to modern animation. Like the zoetrope, the flipbook creates the illusion of motion. A set of sequential pictures flipped at high speed creates this effect. Of the forms of modern animation that we've talked about so far, the flipbook is the only one to survive and thrive in modern times.
The pyraxinoscope was an animation device, the successor to the zoetrope. It was invented in France in 1877 by Charles-Émile Reynaud. Like the zoetrope, it used a strip of pictures placed around the inner surface of a spinning cylinder. The pyraxinoscope improved on the zoetrope by replacing the narrow viewing slits with an inner circle of mirrors, placed so that the reflections of the pictures appeared more or less stationary in position as the wheel turned. Someone looking in the mirrors would therefore see a rapid succession of images, producing the illusion of motion, with a brighter and less distorted picture than the zoetrope offered. In 1889, Reynaud developed the theater optique, an improved version capable of projecting images on a screen from a longer roll of pictures. This allowed him to show hand-drawn animated cartoons to larger audiences.
After the pyraxinoscope, we enter the realm of traditional animation, starting with cell animation. The cell is an important innovation to traditional animation as it allows some parts of each frame to be repeated from frame to frame, thus saving labor. A simple example would be a scene with two characters on screen, one of which is talking to the other and standing silently. Since the latter character is not moving, it can be displayed in this scene using only one drawing on one cell, while multiple drawings on multiple cells will be used to animate the speaking character. In the very early cartoons made before the use of cell animation, the entire frame, including the background and all of the characters and items, were drawn on a single sheet of paper, then photographed, and everything had to be redrawn for each frame containing movements. This led to a jittery appearance.
Stop motion is an animation technique to make a physically manipulated object appear to move on its own. The object is moved in small increments between individually photographed frames, creating the illusion of movement when the series of frames is played as a continuous sequence. Clay figures are often used in stop motion for their ease of repositioning. Motion animation using clay is called clay animation or claymation.
Next came multiplane animation. The multiplane camera is a special motion picture camera used in the traditional animation process that moves a number of pieces of artwork past the camera at various speeds and at various distances from one another. This creates a three-dimensional effect, although not actually stereoscopic. Various parts of the artwork layers are left transparent to allow the other layers to be seen behind them. The movements are calculated and photographed frame by frame, with the result being an illusion of depth. by having several layers of artwork moving at different speeds. The further away from the camera, the slower the speed. The multiplane effect is sometimes referred to as a parallax process. An interesting variation is to have the background and foreground move in opposite directions. This creates an effect of rotation. An early example of this is the scene in Walt Disney's Snow White and the Seven Dwarfs, where the evil queen drinks her potion, and the surroundings appear to spin around.
Xerography is a dry photocopying technique invented by Chester Carlson in 1938. Applied to animation by UB Iwerks at the Walt Disney Studio during the late 1950s, xerography allowed the drawings to be copied directly onto cells, eliminating much of the inking process. This saved time and money, and it made it possible to put in more details and to control the size of Xeroxed objects and characters.
Computer animation is the process used for generating animated images by using computer graphics. The more general term, computer-generated imagery, encompasses both static scenes and dynamic images, while computer animation only refers to moving images. Modern computer animation usually uses 3D computer graphics, although 2D computer graphics are still used for stylistic, low bandwidth, and faster real-time renderings. Sometimes the target of the animation is the computer itself, but sometimes the target is another medium such as film. Computer animation is essentially a digital successor to the stop-motion techniques used in traditional animation, with 3D models and frame-by-frame animation of 2D illustrations. To create the illusion of movement, an image is displayed on the computer screen and repeatedly replaced by a new image that is similar to it, but advanced slightly in the time domain, usually at a rate of 24 or 30 frames per second. This technique is identical to how the illusion of movement is achieved with the television and motion pictures.
Motion capture is the process of recording movement and translating that movement onto a digital model. In motion capture sessions, movements of one or more actors are sampled many times per second. Although with most techniques, motion capture records only the movements of the actor, not his or her visual appearance. The animation data is mapped to a 3D model so that the model performs the same actions as the actor. Camera movements can also be motion captured so that a virtual camera in the scene will pan, tilt, or dolly around the stage driven by a camera operator while the actor is performing, and the motion capture system can capture the camera and props as well as the actor's performance. This allows the computer-generated characters, images, and sets to have the same perspective as the video images from the camera. A computer processes the data and displays the movements of the actor, providing the desired camera positions in terms of objects in the set.